Hi, this is Alex from devstories.eu. Zipline Backtesting Engine, Episode 1 of 7. Most trading algorithms look brilliant on paper, but instantly lose money in live markets. The usual suspect is look-ahead bias. Your code accidentally peaks at tomorrow's closing price to make today's trade. The event-driven backtesting engine in Zipline 3.0 prevents this completely. In a standard vectorized backtester, you load a massive data frame of historical prices and apply Panda's operations across the entire timeline at once. This is fast, but it is deeply flawed for simulating reality. You can easily write logic that triggers a buy order today based on a rolling average that accidentally includes data from next week. Zipline strips away that capability by forcing you into a strict event-driven stream. It simulates an actual financial exchange. When you run a backtest, the engine acts as a strict timekeeper. It steps forward through history, tick by tick or minute by minute. At each step, it fires an event. Your code receives only the data available at that precise microsecond. You inspect the current state, place your orders, and then wait for the engine to advance the clock. You cannot look forward because the future data has not been streamed to the engine yet. This architecture guarantees that your backtest reflects the actual constraints of live trading. However, processing a financial timeline event by event in pure Python creates a massive bottleneck. You might be processing years of minute-level pricing data across thousands of individual equities. To make this event loop computationally viable, Zipline heavily offloads work to C extensions. The core engine relies on pre-compiled routines to crunch the numbers fast enough to be useful. This reliance on C extensions introduces a major friction point. Setting up a robust quantitative environment from scratch is notoriously difficult. Zipline is not a standalone Python tool. It requires deep integration with system-level scientific libraries. For instance, it uses TA-Lib, a standard library for generating technical market indicators. It also relies on packages that need LAPACK and BLAS for heavy linear algebra computations. These are complex legacy C and Fortran codebases. If you attempt to build this environment using a simple pip install command, you will almost certainly hit a wall of compilation errors. Pip pulls down the source code for these dependencies and attempts to compile them locally. This requires your operating system to have a properly configured C compiler, a Fortran compiler, and the correct system header files already in place. Most base operating systems do not have this out of the box. This is why the Zipline documentation explicitly recommends using Conda instead of pip. Conda is not just a Python package manager. It is an environment and system-level binary manager. When you create a Conda environment and install Zipline via the Conda Forge channel, you are not compiling anything from source. Conda downloads pre-compiled binaries for your specific operating system. It handles the C extensions, TA-Lib, and LACACK seamlessly. The dependency tree is resolved for you, yielding a stable environment ready for algorithmic development. Here's the key insight. The strict event loop that makes Zipline mathematically honest is exactly what forces it to rely on heavy, compiled C dependencies to run at scale. By understanding this architecture, you understand why the installation is complex and why Conda is the only sensible way to build your environment. If you want to help keep the show going, you can support us by searching for Dev Stories EU on Patreon. That's all for this one. Thanks for listening, and keep building.